Consider a language over A, comma B that ends with BAA. Design NFA, then convert it into DFA. Find out tuple form, transition table, and transition diagram. So first, we need to construct NFA that ends with BAA. So this is the NFA. So here you can see the minimum string is BAA in the language. And before this, you can have any number of A's and B's. It should end with BAA. So what is the language? Minimum string is BAA. Then it can start with A, but it should end only with BAA. Or it can start with B, but it should end only with BAA. And so on. Okay. So this is the NFA. Now, find out tuple form. So Q is total number of states. So here we have total 4 states. Then sigma input symbols are A and B. Transition function. So Q naught on input symbol A. It is having path on Q naught. So that is Q naught. Q naught on input symbol B. So it is having path on same state as well as it is having one more path to next state. So that is Q naught Q1. Q1 on input symbol A. It is moving to Q2. Q1 on input symbol B. There is no path. So this is 5. Q2 on input symbol A moves to Q3. Q2 on input symbol B. There is no path. So 5. Q3 on input symbol A and B. There are no path. So this is empty or 5. And this is a transition table which should be constructed with the help of this transition functions. So Q naught on input symbol A, Q naught on input symbol B, Q naught, Q1. So write down all these things. Q naught, then 5. Here it is Q2, 5. And remaining are 5. After this, we need to convert this into DFA. So for this conversion, so you can take this first row as it is in DFA table. This is same. Now you need to find out new states or next state. So new state is Q naught Q1. So take that and find out transitions on input symbol A and B. So here delta of Q naught on input symbol A. So Q naught Q1 on A can be written as delta of Q naught on input symbol A union delta of Q1 on input symbol A. So Q naught on input symbol A is Q naught itself. So this is Q naught union Q naught on Q1 on input symbol A is Q2. So we need to take these values from NFA table. So Q naught on input symbol A is Q naught. Q1 on input symbol A is Q2. So we got Q naught Q2. Then Q naught Q1 on input symbol B. So in place of A, place B. Q naught on input symbol B is Q naught Q1. Q1 on input symbol B is 5. So we'll get Q naught Q1. Now find out new state. So we completed Q naught as well as Q naught Q1. So we got one new state Q naught Q2. Find out transitions in the same way, just like how we did here. Then check for new state. We got new state Q1, Q naught Q3. Again find out transitions. Then we got here we don't have any new state, so you can stop here. Okay, and this is the tuple form for the DFA, and this is a DFA transition table, and these are the transitions for DFA. Q naught on input symbol A, it is saying staying in same state Q naught. Q naught on input symbol B, it is going to Q naught Q1. So we need to take all these 4 states as 4 nodes in the diagram. Then Q naught Q1 on input symbol A, it is moving to Q naught Q2. Q naught Q1 on input symbol B, it is staying in same state Q naught Q1. Then Q naught Q2 on input symbol A, it is moving to Q naught Q3. Q naught Q2 on input symbol B, moving to Q naught Q1. Q naught Q3 on input symbol A, moving to Q naught. Q naught Q3 on input symbol B, there is path to Q naught Q1. Next question is, so this is the epsilon NFA. Now compute the epsilon closure of each state as well as convert this epsilon NFA to NFA. So first we need to find out epsilon closure for each state. So for Q naught, that Q naught itself, as well as there is an epsilon path from Q naught to Q1, so we'll get Q1 also. And for Q1, that state Q naught itself, as well as there is epsilon path to Q3. So this is Q3. For Q2, there is no epsilon path or outgoing arrow from Q2 on input symbol epsilon. So this is that state itself. Then Q3 also, it is not having any outgoing edge with epsilon. So that state itself Q3. So this is a notation. Delta dash of Q naught on input symbol 0 can be written as epsilon closure of delta of epsilon closure of Q naught comma Q naught. Epsilon closure of Q naught is Q naught Q1. So this can be written as Q naught on input symbol 0 union Q1 on input symbol 0. So Q naught on input symbol 0 is Q naught. Q1 on input symbol 0 is Q2. So here we are having epsilon closure of Q naught union Q2. So for Q naught union Q2, we'll get Q naught Q1 and Q3. Then find out delta dash of Q naught on 1. So Q naught on 1 can be written as epsilon closure of delta of epsilon closure of Q naught comma 1. So epsilon closure of Q naught is Q naught Q1, which can be written as Q naught on 1 union Q1 on 1. So Q naught on 1, there is no path, so phi. Q1 on 1, there is no input path, so this is also phi. Q1 on 0 will get epsilon closure of Q2 union Q3. So Q2 union Q3 is nothing but Q2 and Q3. Then delta dash of Q1 on 1. So here you can see delta of Q1 on 1. There is no path, so it is phi. Q3 on 1. There is no path, so this is also phi. Then Q2 on 0. So epsilon closure of Q2 on 0 is Q2 only. So delta of Q2 on 0, there is no path, so it is phi. Then epsilon closure of Q2 on 1, there is no path. So epsilon closure of Q2 is Q2. Delta of Q2 on 1 is, there is a path to Q1. So find out epsilon closure of Q1. It is Q1, Q3. Then Q3 comma 0. So delta of Q3 on 0 is, it is having self loop. So this is epsilon closure of Q3, which is Q3. Then Q3 on 1. So delta of Q3 on 1, there is no path, so it is phi. So after finding all these transitions, we need to draw transition table. So Q naught on 0 is Q naught Q1 Q3, on 1 phi. Q1 on 0, Q2 Q3, Q1 on 0, Q1 on 1 phi. Q2 on 0 phi, Q2 on 1 Q1 Q3. Q3 on 0 Q3, Q3 on 1 is phi. And this is the NFA without epsilon, which is constructed with the help of this transition table. Given regular expression using subset method. So here first check this term. This is in the form of A plus B. Again, This is in the form of A plus B. So what is A plus B notation? This one. Okay, so this is a notation as we are having two input paths A. In this B plus A, we wrote it like this. After this, B star. So you need to multiply this complete term with B star. So B star is represented in this way. And this is B plus A. So you need to multiply both the terms. And here B star is again multiplied with A. So you can see epsilon in the middle. So that is the notation. So you need to go through all the three rules for drawing this. So one is for A plus B, then A into B, then A star. After this, we need to add this complete result with A plus B. So here in this diagram, you can see this is A plus B. This is a notation. So we are adding this upper part with this lower one. So that is this term. So this is in the form of A plus B. This complete term becomes B. Then next one is convert the given DFA into regular expression using Arden's theorem. So first take this DFA and find out equations. First A equal to, check the incoming arrows. It is having incoming edge from B on input symbol B. So this is BB. Then it is having incoming edge from C on input symbol A, which is C dot A. As is the initial state, we need to add epsilon at the end. Then B having incoming edge from A on input symbol A, so it is A dot A. And it is receiving input symbol B from state C. So this is C dot B. Then C, it is having incoming edge from A on input symbol B. So that is A dot B. Now we need to solve this final state. So in order to solve A, we need B as well as C. Okay. So first let us solve this B. So B can be written as A dot A plus C dot B. C is nothing but A dot B. So we'll get it. So in place of C, we are writing this A dot B. If you take A common, you will get A into A plus BB. So this is B. Now we need to substitute that B in place of this B in equation A. So then we got A into A plus BB plus, in place of C, we need to write A dot B dot A plus epsilon. So here B is A into A plus BB dot B. So we need to write this B also. Then you can see A common in both the terms. So take A common, A into A plus BB plus BA. So you'll get AB plus BBB. So this can be written as AB plus BBB plus we are taking this B dot A common. So this is in the form of R equal to RP plus Q. So this is A is R and this complete term becomes P and we have epsilon. So it can be written as R equal to QP star. So what is Q? Epsilon, and P star is AB plus BB B plus BA. This is P. So we need to take whole star. So this is your final regular expression for this given DFA.